All right, guys, here we go. We're going to talk about 1.08 solving quadratics using square roots. So we're going to review a little bit as far as simplifying these expressions or simplifying these square roots. When you're simplifying a square root, what you're looking for is what can come out and what has to stay inside. Square roots, you're looking for something that has been multiplied by itself, if you will. So when we look at just a simple example, the square root of 4, it equals 2. The reason why is because 4 equals 2 times 2. It's a perfect square. 2 times 2, that's why it's equal to 2. So when we do this, we know that there's no number that can multiply to give me 12. So 12 isn't a perfect square root, so we got to find what numbers can multiply to give me 12, and are there any perfect squares in them? So we have 4 times 3, 6 times 2, or 12 times 1. Well, the only one that has a perfect square is that one. So this would come out as the square root of 4 times the square root of 3. Because you can't take it outside the square root, they got to stay underneath the square root. You just got to determine which factors of 12 could possibly give me an option to pull something out. Square root of 4, we already know from up above, is 2. Square root of 3 cannot be simplified. It's simply 3. And that's that. Technically, it could be positive. No, it's not going to be positive and negative because we're not solving. So skip that. Sorry. Ahead of myself here because I'm thinking of solving. All right. So here we got a negative 45. Before we can even do that, we need to understand, we need to take that negative, square root of negative 1 out. Okay? And we need to remember that the square root of negative 1 equals I. This is an imaginary number. Can't possible. If you put that in a calculator, you're going to get error. Okay, so it can't work. It's not algebraically. It doesn't really make sense. So we got to take this out, if you will. So this is equal to I. So now we got to determine what numbers 45. Well, we have 1 and 45. 2 doesn't go. 3 and 15. 4, 5, 5, and 9. Those are our factors of 45. That's not a perfect square in there. That's not a perfect square in there. That is a perfect square. So we would come out here and we have square root of 9 times the square root of 5. Square root of 9 times the square root of 5 is, square root of 9 is 3. Square root of 5 stays inside. And we have to remember this I is still here. So technically the I comes out as well. So it is 3I root 5. Okay? 3I root 5. And remember, it needs to go in the order of, when you write these things, it needs to go in the order of a number, the I, and then the root. A number, then the I. Don't put the I in front of the number. Don't put the I in the back of the square root. It's written in this order. The number, the I, then the root. We're going to go ahead and just take this I out. We know we have an I. So we got square root of negative 1 equals I. Okay, square root of negative 1 equals I. Now we're going to deal with the square root of 72. All right, so we want to look for the largest thing we could come out. So we'll start with this 1 times 72. Well, 72 is not a perfect square root. 72 divisible by 2. 2 times 36 gives us 72. Bang, bang, bang. We don't need to go further. We've got a big old square root, a perfect square right there that we can take out. So we can say that we have the square root of 36 times the square root of 2, which is simply 6 root 2. I. So it's 6I root 2. Again, number, I, square root. Number, I, square root. Hopefully there aren't any questions with that. I'm going to roll up just so I get a little bit more onto the screen as we go through this. And it makes just a little bit cleaner view for everything. So we're going to start talking about solving quadratics, finding the square root. Okay? These are a bunch of instructions. I don't like a bunch of words and instructions. You know what I like? I like little things that are simple. So remember how when you're trying to expand upon things, and we used to use PEMDAS, you got to do the parentheses first, then the exponents, then multiply, divide, add, subtract. Well, that's when you're trying to expand a polynomial, if you will. So to solve for these quadratics, you actually use reverse PEMDAS. So when you use reverse PEMDAS, there's a few things that go in order, okay? Add and subtract go together. They're inverse properties. If you add it or you subtract it, if something's being added, you subtract it, takes it away. If something's being subtracted, you add it, it negates it. What we're trying to do is simplify or negate things. Multiply and divide go together, so that's its own little box. Exponents go together, and parentheses go, or exponents go by themselves, and then parentheses is by itself. So we're going to do reverse PEMDAS. So when I look at this equation over here, and again, it is an equation. It has an equal sign, so that means I'm solving. If it has an equal sign, I'm solving. You can follow these instructions here. I'm not going to do that. I do reverse PEMDAS, okay? So I want to get my x. I want to solve. So I want that by itself. I'm trying to solve for x. So I need everything else out of the way, and x by itself. To do that, I need to do reverse PEMDAS. Okay, it's going to help us to determine which steps to take. Well, it tells me I need to either add or subtract something. Well, this is being subtracted by 9 here, so we'll just add 9 to both sides. The process will end up with x squared equals 16 plus 9 is 25. Done. The next one says I need to multiply or divide. Well, is there anything I need to multiply? Is there anything I need to multiply or divide? There's nothing in front of this. There's nothing really to multiply or divide, so I can skip that step. The next step is for exponents. It says an exponent. So to get rid of an exponent, you do the inverse property of that, which is to tell you take the square root. So if I do something to one side, I have to also do it to the other. In that process, square root of x squared is x. The square root of 25 is 5. However, technically when you're solving for this, it has to be plus or minus 5. The reason for that, remember how we did this, right? The reason why the square root of 25 is 5 is because 5 times 5. So 2 of them. What number can multiply together to give me the inside the radical? 5. Same thing though. 25 could technically be negative 5 times negative 5. Hence, positive or negative 5. That's why. Negative 5 times negative 5 is 25. That's why it's positive and negative. Okay? Also, when we graph it, it's going to look like this little U shape, and this will be over here. If we had our little graph like this, you know, our XY axis, then we'd have this right here. We'd have our X value would be at negative 5, and our our other X value will be at X. That's visibly Y. This is algebraically Y. Okay? Let that sink in. Here we're going to do PEMDAS again. I'm going to keep the PEMDAS up. I'm just going to keep putting X's and stuff through it. I'll do a different color to kind of give us a different feel, if you will. So right here it says to add or subtract. Well, I have x squared plus 81. I want my x by itself, so what do I have to do? I need to subtract 81 from both sides. There's my add or subtract. So now I have x squared equals negative 81. Now I go through, is there anything to multiply or divide? There is not, so I don't have to worry about that. Is there an exponent? Yes, there is an exponent, so I need to do the inverse property. Take the square root, take the square root. The square root of x squared is simply x. The square root of negative 81. So let's do that over here to the side. What do? We know that this comes out. And then we also have 81. Well, 81 can be 9 times 9, hence that's why it's 9. This is I. So the square root of negative 81 will be 9i. It doesn't matter that this is negative, okay? That negative comes out with the I. The fact that the square root of 81 is still positive or negative. The reason behind that is simply put, let's do it. Let's just go for it the same way I did this. So here I have negative 81. It could be 9i times 9i. Well, it simply is 9 times 9 is 81. I times I is I squared. Remembering that I squared equals negative 1. So this is negative 81. Same way if you did it the opposite. Negative 9i times negative 9i, that's times by the way, is negative 9 times negative 9 is still 81. I times I is still negative, I squared, so it's still negative 81. So hence, positive and negative. All righty, let's go, let's go, let's go. I'm going to erase this one over here just so we have a little bit of space. And it doesn't, I'm going to leave that there so it can sink in a little bit longer. Try a few different colors. Here, we're going to use PEMDAS or reverse PEMDAS again. And we're going to put it in our little boxes. 4 things that go together again. Okay? So here, this would be confusing for some of us. We go, well, I don't know which one to do. I have this number out here. Do I do this? Do I do this? Follow reverse PEMDAS. Are there other ways you can do it? Absolutely. But if you're confused by the overall process of it, just use reverse PEMDAS and always stay consistent. Add, subtract. Well, this is added 5, so I want to subtract 5. So I have 2x squared equals 36. Now I have 2x squared equals 36. Well, is there anything to multiply or divide? This is being multiplied. So yeah, I want to divide it by that 2. I want to get that x by itself. To do so, now I have x squared equals 18. In the process of that, we talk about exponents. Or exponents, we do the inverse property. The square root of x squared is x. The square root of 18, I don't want to go through all that, is simply 3 root 2. However, it is positive or negative. Do you want to see why that's square root? Let's do it. Why not? Let's just do it. So we're saying that the square root of 18 is 3 root 2 times 3 root 2. Correct? Why? Why? Well, when you multiply these two things, you always multiply the numbers, which 3 times 3 is 9. And then you multiply these numbers, but they stay inside a radical. What is 2 times 2? 4. So now I have 9 times the square root of 4. What's the square root of 4? 2, 18. Da-da! For all of us who just plug stuff into a calculator and really don't understand the reasoning behind, that's why. So please understand, and then the negative is going to be the same thing. I'm going to negative 3 times negative 3 is still 9. Still going to be the same thing. Okay? So I'm going to let that sink in, and I'm going to go to the next one over here, which is going to be number 4. Number 4 is pretty interesting in the fact that I'm going to try, I'll keep these colors, I like these colors. I, again, am going to use reverse PEMDAS. Okay, so I can look at this and I can solve it. Okay, I'm pretty good at that. I can do this kind of in my head. Unfortunately, a lot of us, when you start dealing with fractions, we don't know where to start. Always having a plan or a game plan is crucial in everything in life, but particularly when you start dealing with something that you're not quite sure of. So if I was to look at this and all of a sudden just go, oh, well, I can do this, I can do that, as opposed to saying, I'm solving for quadratics, I'm going to follow reverse PEMDAS. So what do? Add, subtract. That's being added, so I'll subtract. Now, multiply, divide. This is being multiplied by 1 over 5. Now, while you can divide both of them by 1/5, sometimes that gets confusing for a lot of us to understand what I would do with this. That gets confusing. I don't want to do that. I don't want to explain that. The easiest way to go about this is to understand that you can always multiply any fraction by its reciprocal and it'll cancel. 5 times 1 is 5. 1 times 5 is 5. 5 over 5 is 1. You don't write 1 in front of it. There's no 1 in front of this x. It's understood. However, what I did, multiply this by 5 over 1, I also have to do it by 5 over 1 over here. The difference between this one and the previous one is technically this is 8 over 1. You can rewrite that as 8 over 1. These canceled out because it ended up being 5 times 1 and 1 times 5, which is 5 over 5. Here I have 1 over 8 times 5 over 1, which is not going to cancel out. My x squared stays up here, and now I have 8 times 5, which is 40, over 1, which is simply 40. And now I have done my multiply and divide. Now I want to go and I want to do my exponents, square roots, x. Square root of 40 is a hard one for a lot of people. They think that it simplifies more than it does, but it's technically, obviously, positive or negative, 2 root 10. That's a difficult one. 30 is a difficult one. 40 is a difficult one because we think that it does more than it actually does. The square root of 30 technically does not simplify. A lot of people want to simplify it somehow, some way. It doesn't. The square root of 40 is that's the highest perfect square that is a factor of 40. 8 is not a perfect square. 8 times 5. So you'd have to simplify it down. So this is the final answer. Okay? I'll let all those sink in. All right, guys, these problems are going to give us a little bit of a challenge. There's a lot of stuff going on. I'm going to go ahead and write my reverse PEMDAS up here at the top for all of them because it's going to be, these problems are crucial to follow reverse PEMDAS. Okay, not every one of them, some of them more than others, but I will be consistent until we get good at this, really good at this. So this one would cause a challenge for a lot of us. But reverse PEMDAS, we can follow a protocol. This is being added, we'll subtract. This is being multiplied, divide. To get rid of this fraction, I want to multiply by its reciprocal. Same thing over here. Negative 5 is like negative 5 over 1. These cancel, go bye-bye. Now we got to go through exponents. Exponents. Well, get rid of my exponent. I take the square root. My parentheses basically tells me just to get rid of it. That's pretty much all that is. Now we've got all the way through reverse PEMDAS. I advise you to simplify this first. So now I have x plus 7 equals plus or minus, 2i root 5. That's how that simplifies. I'm not going to keep going through every one of those. You should be able to do that. Once you run out, you loop back around. This is being added, so I'm going to subtract it. Now I have my x. Crucial understanding. Remember, like that. This is my bi. That means that has to be my a. And that's your final answer. And again, remember, quadratics tell me I have two answers. So this answer is technically negative 7 plus 2i root 5. And negative 7 minus 2i root 5. You have two answers. Quadratic, two solutions. Plus, minus. That's why you have to be consistent with that. Okay? Let's go over to the next one. Here I don't have anything multiplied or, added or subtracted on this side, so I don't have to deal with that. I do have something multiplied. I have this 2 multiplied, so I'm going to divide it by 2 on both sides and end up with x. Almost root. Well, there's the bell. Minus 3 squared equals negative 4. Done. I'm going to take my square roots, get rid of my exponents, and I'm left with x minus 3 equals square root of negative 4. Please understand that this simplifies, and I'm going to get rid of my parentheses all at the same time of x minus 3 equals positive negative 2i. Then I got to loop back around again, add 3. Remembering that this 2i is my bi portion. So I have x equals 3 plus or minus 2i. X equals 3 plus 2i. X equals 3 minus 2i. Two solutions. Those are the two. Okay, I'm going to let that sink in, leave it there while I finish, do the next one. Again, reverse PEMDAS. Try a little bit different colors just to kind of mix it up so everything doesn't blend together so much. Okay. Subtract, add. Add 6, add 6. Multiply, divide. Divide. Exponents, square roots. Simplify. And I'm not going to go through why negative square root of negative 12 is positive negative 2i root 3. At this point, you should know that. Two answers. Positive 2i root 3, negative 2i root 3. Next one. PEMDAS. Anything added or subtracted? No. Multiply, divide? Yes. Cancels. Being consistent is crucial. This isn't the square root. That's 100 divided by 4, so it's 25. Did that? Exponents. This one's going to, square root of 25. What did I do there? Get rid of my parentheses all at the same time. Positive, negative 5. Little bit different feel for this one now. Loop back around. Add, subtract. This one now looks like you can't leave it like that. You have to go to it like this. Let me do it down here. X equals negative 1 plus 5 equals 4. X equals negative 1 minus 5 equals negative 6. Can't leave it like this. Got to be able to work it out. 4 and negative 6. Cool beans, cool beans, cool beans. All right. So let's erase a little bit and let's get down to that application problem that everybody loves so much. This one's going to be a tricky one. No, this is the increase. The decrease is the tricky one. You know what? I want to do the decrease. That's what I want to do. I want to do the decrease one because I think it's more challenging personally than the increase. Okay. We're going to come all the way down here to the homework stuff and do the decrease. Okay, it says if the sides of a square are decreased by 2 inches, the new area is 64 inches. What is the area of the original square? So here's my original square. Original square. I don't know what it is. So I'm going to call it x times x. I don't know because it says the area of the original square is, I don't know. It says then that my sides were decreased by 2 inches. So this is basically, let's just call it decreased by 2 inches. So now this side here, or this new box right there, if you will, is technically x, which is the whole thing, minus 2. Because it's x minus 2, which means this is x minus 2. And then it tells me that this whole little red square is 64 squared inches. So I need to determine what x is. I don't know what x is, but I can use what I know in red, which is area equals length times width. So I have 64 equals x minus 2 times x minus 2, which is 64 equals x minus 2 squared. Square root both sides, which leaves me at positive negative 8 equals x minus 2. Add 2, add 2. So I have 2 plus or minus 8 equals x. So if I have x equals 2 plus or minus 8, I have x equals 2 plus 8, x equals 10, x equals 2 minus 8, x equals negative 6. X is a length. Length. I can't say my room is negative 6 feet long. So negative 6 is a no-go. So that means that 6, while negative 6 solves the problem, it can't be a solution. So x equals 10. When I go back to my original square, what's the area of my original square? Well, the area, let me do it in blues to be consistent. The area of the original square is x times x. Well, x equals 10. So the area of the original square was 100 inches squared. If you think about it, if this is 10, if x is 10, 10 minus 2 is 8. 10 minus 2 is 8. 8 times 8, 64. Hope that works. See you next time.